Hello guys, welcome to today's class. In this class, we will have a general introduction to Kirchhoff's law. Kirchhoff's law is an important topic in electrical circuits analysis. They are fundamentals to understanding and solving complex electrical circuits. Okay. Let's get started with the basics. Kirchhoff's law was introduced by a German physicist in 1845. His name is Gustav Kirchhoff, and these laws are essential for analyzing electrical circuits. You all know that basically Kirchhoff's law consists of two laws, that is the Kirchhoff's current law and Kirchhoff's voltage law. In short, we will say it as KCL and KVL. KCL deals with law of conservation of charges, and KVL deals with the law of conservation of energy. Okay, so let's see what is KCL. KCL states that the sum of all currents entering a node is equal to the sum of all currents leaving a node. We have seen what are nodes, what are meshes, what are branches, what are loops in a previous class. So in any circuit, the algebraic sum of current meeting at a junction is 0. Okay, so if I have a circuit like this, so what KCL states, I have a node, the algebraic sum of all the currents entering a node. Okay, let it be this current be entering like this, that is I1. Let it be leaving like this, I2, and this also is entering I3. Okay, so KCL states that the algebraic sum of all the currents entering a node or meeting at a node is equal to 0. Mathematically, we can represent it as current entering is equal to current leaving. Okay, or we can say summation of I in is equal to summation of I out. Okay, so here I1 and I3 are entering current and I2 is a leaving current. So we can say I1 plus I3 is equal to I2. Okay. So this is what Kirchhoff's current law says, and it is mainly used for the nodal analysis of the electrical circuit. Okay. So in electrical circuit, whenever we do the nodal analysis, we use Kirchhoff's current law. Now, this law is based upon the conservation of charges. It means that in the node or at the junction, what charge will not accumulate. Okay, charge will not accumulate in the junction. It is just a junction. It just passes the charge to the next branch. At the branch, neither they store the charges nor they produce the charges or they add the charges. So it is just acting like a junction. Okay. So this is what Kirchhoff's current law says. Next, we can see Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of voltages in a closed loop is equal to zero. Okay, in a closed loop, the algebraic sum of all the voltages is equal to zero. Okay, mathematically we can write is delta V is equal to zero. Okay, around a loop. Okay, or around a mesh. Mesh is the shortest or the smallest possible loop in an electrical circuit. So around a mesh or around a loop, the algebraic sum of all the voltages is equal to zero. Okay, so it is based on the conservation of principle of conservation of energy. That is, energy is neither created nor destroyed in a closed loop. Okay, so next we can see the sign conventions used. Sign conventions. In electrical circuit, in order to write the loop equation, okay, in furthermore in any other subjects like in electronics, analog electronics, you will have uh, more analysis of BJT. In power system, you have to write loop equations. So all this in all those subjects, we are using this basic fundamental uh, method or basic fundamental sign convention. So what is a sign convention? If we have a voltage source like this, say it as V, and if we are moving in this direction, okay, if we are moving in this direction, we can see that at this is a branch. Okay, consider this is a branch and it is connected between two nodes A and B. At node A, we will be having a negative potential. Okay, say it minus 5 volt. Assume it as minus 5 volt. And as we move to node B, it will become positive 5 volt. Let it be positive 5 volt. Okay, means what do you mean? As we move from node A to node B, there is a rising potential, right? There is a rising potential. There is a rising potential. So we call, as we move, we will take it as plus V. Okay, whatever be the value of V, we will take it as plus V. Now consider the voltage source connected like this between the node A and B, okay, whose value is V. So at node A, it will be having a plus voltage, positive voltage, and at node B, it will be having a negative voltage, or let it be 0 volt. Okay, so what happens as we move from A to B, there is a drop in potential. So we take it as minus V. Okay, so this is the first sign convention. In a circuit, whenever we go from one node to another node, and in the direction if we are going from negative potential to the positive potential, we will take it as a plus V. And if we are going from a positive potential to negative potential, then there is a drop in potential and we will take it as a minus V. And if we are having a resistor, okay, if we are having a resistor R, and we don't have in the question if there is no sign convention given, okay, we will usually assume the direction of the current as this. Suppose we are assuming, then it will be plus and this will be negative. Okay. What will happen when the current flows through the resistor? There will be a potential drop. Okay. The word itself says there is a drop in potential. So potential drop is always shown as minus. Okay, minus IR if we are moving in this direction as the direction of current. If we are moving in the same direction as the direction of current across the resistor, there will always be a potential drop and it will be taken as minus IR. Okay, and if we are going in the opposite direction to the normal sign convention, okay, if they are given like this and if we are going in this direction opposite to the current direction, then we will take it as plus IR. Okay, so always remember, if we in my case, whenever I take a circuit, we are doing the analysis. So whenever I take a circuit, I usually put the direction in which I move and the current direction as same. Okay, I'll take always the current direction in the clockwise direction and I'll move in the current direction. So there will be always taking it as minus IR because there is a potential drop. Suppose in some questions, if they are given the current direction like this or current direction in the opposite direction to the plus minus. Okay, in that case, you have to take it as plus IR. Okay, so usually we will go with this one. Okay, so whenever there is a drop in potential, we should use minus V, and whenever there is a rise in potential, we will use it as plus V. Okay, so uh, in the current KCL, we have seen summation of I in minus I out is equal to 0. Okay, that is current entering is taken as positive and current leaving is taken as negative. Okay, so this minus means taken as negative. Current entering, or we can write it as current entering is equal to current leaving. Okay, so in now let's see how we can apply the Kirchhoff's voltage law in a simple circuit as shown in the figure. So here we have a voltage source of 12 volt and 2 ohm and a 4 ohm resistor. So first we have to draw the current direction. So this is my assumed current direction as well as the way in which I travel. So first we have to give a ground. Okay, assume there is a ground and we have to move from this point. Okay, so as we move, we can see this node is having a low potential and this this node is having a high potential. So we will write applying KVL. What you will write? 12 volt. Okay, 12 minus. Okay, so then there is a resistance and the resistance will always have a voltage drop. So it is minus I2. Okay, that is I into R or 2I. Okay, then here we have the 4 ohm resistor, again a potential voltage drop, that is 4 into I is equal to 0. Okay, so the KVL says summation of voltages is equal to 0. Here I have a voltage and the voltage here is I into R and the voltage here is 4 into I or I into R again. Okay, and these two are having a potential drop, so we wrote it as minus. Okay, now I can write 12 minus 6i is equal to 0, or I is equal to 12 by 6, which is equal to 2 ampere. Okay, so the current flowing through the circuit is 2 ampere. So this is a simple circuit and we have done the analysis like this. Okay, so I hope you have a clear idea about how to apply Kirchhoff's law in a simple circuit. What you should take it as a sign convention when it is a resistor, and if we are moving in the same direction as a current, you should take it as a voltage drop. And if there is a rising potential, you should take it as a plus voltage, and if there is a drop in potential, you should take it as a negative voltage. I hope you are clear with all these things. Then we are going to the applications of Kirchhoff's law. So Kirchhoff's law is basically applied for electronic circuit designing, then power grid management, then troubleshooting faults in electrical circuit, and analyzing complex networks in engineering. Okay, I hope you got a clear idea about the subject. We have seen that KCL states that current entering a node is equal to current leaving a node, and KVL states that sum of all voltages in closed loop is equal to 0. And these laws are tools for analyzing and solving any electrical circuit. Thank you for attending today's class on Kirchhoff's law. Make sure to practice more problems to solidify your understanding. If you enjoyed the session, don't forget to like and share and subscribe for more videos on electrical engineering concepts. See you in the next class. In the next class, we are going for the mesh analysis. Uh, we will see pretty much problems on this and see how we can write uh, mesh equations for a wide variety of circuits. Thank you. See you in the next class. Bye.